Okay, I think we'll try to get started and stay synchronized with the other session. Good morning, and thank you very much for joining us this morning at the session that we put together. My name is Dave Demore, and my colleague Paul Hennon and I are co-convened this session and tried to put together a different kind of approach to transcending boundaries. Of course, our title is Transcending Boundaries Across Human and Natural Systems of the North Coastal Temperate Rainforest. Originally that vision was kind of one where we thought we would just kind of look at maps and try to link things, and so we decided to take in a little different area and look at different types of boundaries and kind of expand our thought process in the theme of the Coastal Temperate Rainforest Center in terms of really broadening our perspectives, increasing outreach and education, and integrating across disciplines. So that was our vision for this session. And we have a great lineup of speakers this morning. I'll be saying a little bit more about each one of them, but Paul's going to kind of give you a sense of who our speakers are and what boundary they're going to be transcending for us.
Yeah, thanks, Dave. This is pretty fun. As Dave and I started to think about this and talk to other people, we were, as Dave said, we were kind of entertaining the idea of boundaries and maps and maybe a couple international boundaries that are really important to us. And then we just got more creative, and we started making lists of all the boundaries we could talk about, and it became sort of this exhaustive list. And I was thinking of like boundaries like the phyloplane, like what happens at the leaf surface, between the surface of a leaf and the atmosphere. We could have kicked that one out, but so we have some more meaningful boundaries today. But it was a fun exercise. We have Steve Langdon, our first speaker, will talk about Native Alaskans and some of the boundary issues, historical boundary issues for them. Rick Edwards will talk about the boundary where the ecosystem, terrestrial ecosystem meets the aquatic system and the ocean system. Gretchen Harrington will talk about where salmon crosses various boundaries. That's pretty obvious. As is the next one, Jim Chu will talk about migratory birds crossing vast areas really. Ken Lertzman will take a little bit different twist on things. Talk about, I think, the boundaries between humans and ecosystem sort of boundary. And then I think John Mankowski will pull this all together with a pretty broad discussion of from the perspective of the North Pacific LCC, and hopefully kind of tie some of these things together.
Yeah, thanks, Paul. So I'd like to introduce our first speaker, Dr. Stephen Langdon from the University of Alaska, Anchorage. He's a professor of anthropology there, where he's taught since 1976. The primary focus of his work in research in Southeast Alaska has been on Tlingit and Haida salmon fishing in pre-contact times and the transformation of those fisheries with the advent of commercial fishing and fisheries management following the assumption of jurisdiction by the United States in 1867. He's conducted both archaeological fieldwork and extensive work with elders on site through participant observation and interviews on these topics. Please welcome Dr. Steve Langdon.
Good Shish, and thank you to all of you for being here and attending this session. I'd like to, first of all, recognize and honor the clans of the Aakw'taatseen, the traditional Tlingit owners of this land upon which we're holding this conference. And I'd also like to pay my respects with regard to the traditional scholars and the elders who have taught me and contributed so much to my feeble efforts at understanding traditional concepts. And we had an absolutely wonderful overview and specific presentation from Dr. Elaine Abraham today. I hope that people go back and look at that very carefully and think about it, because Elaine's a very special traditional scholar because she is grounded in an academia, so she's able to bridge that particular transition and the other one of language in a remarkable way, and she does a wonderful job. We have other traditional scholars with us in this room, some of whose concepts I'll reference today. David Katsik of the Shunkwedi clan. And I also want to reference the work that any of us do is built upon not only all of these networked individuals that I mentioned, but also others. The interdisciplinary quality of my work has also benefited greatly from the work of Thomas Ager, who's a terrestrial paleoenvironmentalist, who's given us an understanding of how our wonderful and beautiful rainforest is transformed through time. Also, a friend and colleague, Jim Bachdahl, whose attention to the production of the carcitic forest in southeastern Alaska is remarkable. But most recently, his dramatic examination of sea level changes in the Holocene and his ability to use those models to predict ancestral locations in the time period between 6,000 and 10,000 years ago quite successfully, remarkable. The work that was referenced by Elaine, Dr. Frederica de Laguna, in providing a very a remarkable foundation with regard to the Aakw'taatseen, which unfortunately is not replicated for the whole region. The marvelous work of Richard and Nora Dauernhauer in the translation of Tlingit oratory and the careful attention to linguistic meaning. And this is absolutely essential to what goes on, and it hasn't been referenced enough, but perhaps because in the context of being an anthropologist, this is a central conceptualization. Part of osmotic movement is the translation of the conceptual basis, and the Tlingit conceptual basis is enormously complex, and requires the kind of work which Richard and Nora Dauernhauer in their lives have devoted to that particular aspect. And finally, I would reference also my colleague Thomas Thornton, whose marvelous book called Place and Being, concerning place names and complex linkages to Tlingit being and culture and social process, should be a foundational document that everyone who's working in southeastern Alaska is familiar with. So let me just say that I'm using osmosis in an analogical fashion, whereas boundaries seem to indicate lack of osmosis is interpenetration. And so what I'm talking about is how this, in this sense, second sense, is a means of linking a set of phenomena that are typically not seen to be connected. And this is one of the great challenges, is to, and as Dr. Oren said, these are the fundamental foundations actually of science. It's not normal science, it's discovery, where those new entities emerge, and that's sometimes referred to in science and technology studies as what is called dynamic nominalism, which is that you have to have a way to think about something, and that requires naming. The concept of string theory, for example, that naming doesn't occur until a particular historic moment. So this is a critical part of what's going on, is these interpenetrations of concepts. So classically, Western ontology, this is the domain of the Southeast Alaska region as it's mapped by in the traditional territories, indicating the Tlingit Kwans, and then they are typically and traditionally divided, quote unquote, into this kind of a boundary of north and south. It's sort of a classic boundary making of modernist typologies, but in fact interpenetrations are ongoing in osmotic movement across these things all the time. So this particular cosmology of Western science, which divides categories and considers them bounded and distinct, for example, species. And there are a number of these kinds of categorical boundaries: nature and culture, organic and inorganic, living and dead, rational and irrational. By contrast, Tlingit and Haida concepts and practices display a different ontological construction of the dynamic intersections and the processual relationships among entities of existence. By that I mean these include transformation amongst forms. Raven, the great ancestral transformer, is capable of taking many forms. There is the shared intrinsic beingness, which Elaine gave us absolutely wonderful examples of how that fundamental underlying ontological construction informs all perception and behavior. And this is a foundational understanding that has to be transmitted and has to be translated and has to be comprehended at a base to move into what we want to do to understand. So what I'd like to do is try to explore what I refer to as actor networks. And this is a form of scientific exploration, was called scientific technology studies in which all of the entities, they're called entities, are brought into connection as they appear in the context of a particular regime. The actor network heuristic provides a perspective that links together those perceptions with the concepts, with the mythic foundations, and then how they are translated into behaviors. This is not a typical approach of the way in which science deals with things out there, but this is the way in which real life is lived and practiced by the people of this landscape. As you will see, the comparisons of these particular kinds of ontologies represents some rather different kinds of things. Actor network theory looks to entities overlooked. It does not a priori categorize that entity, and it does not assign causality. It looks for translations and mediations that constitute the forms of these connections. Actants can be of various sorts: objects, perceptions, concepts, constructs, and living forms. And this particular approach allows us to look at alternate connections that provide new insights, understandings, and investigative frontiers. So the alternate ways of existing in the coastal rainforest environment. In the Western scientific ontological framework, I think, therefore I am. This constitutes the differentiation of thought from feeling, the prioritization of thought and over emotion and feeling as rational and preferred, and is the basis for scientific investigation, but not necessarily for behavior. In the merged TLINGIT ontological framework, I think and feel. They are not distinguished. They are ongoing parts of living in the real world. I perceive others, all forms of others, as Elaine talked about. I must, and that's categorical. I must relate and respect others in order to be. And this is fundamental in the structure of the TLINGIT society, and that society informs the rest of the way things are. And that is, you cannot exist as Robinson Crusoe in TLINGIT society. You must have another side. You are only the part of a marriage of two coming together. The notion of self-sufficiency is absolutely impossible. So therefore, this particular relationship and respect is at the foundation in terms of how life has to be lived. So the basis for relational acts and therefore all sustainable existence comes from this particular ontological framework. Now, Elaine, one of the classic ones, I'm going to be talking specifically about salmon today, so I'm just going to give a very brief example of the mythic structure that underpins this foundation. And from the language, again, this language forms what I refer to as a habitus. That's dynamic nominalism from a philosopher named Pierre Bourdieu. Habitus is what informs your daily living perception and your fundamental reactions to things, much of which you're simply unaware of until it's exposed to you. That's part of Elaine's wondrous ability to move, is that she can operate, and I could give examples of how she operates in her TLINGIT habitus, but then she has the capacity to deal with it in another fashion. So Aakw'taatseen, and the name translates as alive in the Eddy, which I'll come back to a little bit later on. But this is a story then about how salmon are really beings, and about how a young boy who violates and disrespects salmon is taken by salmon into their homes offshore. He's taught and demonstrated how they are in fact people like him, and how they are to be treated. He is then transported back where he is harvested by his parents, and through a spiritual transformation, he returns to the land of human beings, and he conveys that knowledge in this mythic structure. When I interviewed elders, people over 50, and I hope in the future all people, this is their foundational answer to what were you taught as a young person about salmon. So it's the foundational habitus. One of the most unique aspects that will bleed through here later on is that as the young boy is returning back to his village, he is told by the chief of the salmon to stand up to see where they are. And not knowing that he was a fish, actually standing up means jumping out of the water. And so when TLINGIT at the mouth of all the streams see salmon doing what? Jumping up when they're returning, they affirm. They will say, "I-O." That is a fundamental principle of relationality, which is affirmation of existence. That's the first part of the protocol. The very first part of the protocol of the affirmation of existence is in that particular domain. So this story then, and I'll come back to Alive in the Eddy later on, this is again how ANT allows us to link things together. This is a carved wood stake that was found on a fish trap so that it, at high tide it is stuck out of the water that George Emmons collected in the 1880s. So as the salmon are returning to this stream and they jump out of the water, this is constructed so that they can see it. And what are they seeing? At the first level, they're seeing a creation of the salmon boy myth. That is an aesthetic representation of that phenomena. So when the salmon sees it, they will recognize these people know what we are about. Secondly, and I would argue just as importantly, and you'll see later on, aesthetics is a part of the relationship. It is a gift. Beauty is a gift in the relationship. And this comes through in all of the ways in which Tlingit use regalia in the context of their own society. This transforms, in this particular case, to their relationship with salmon. Our honoring of you through the gift of beauty ensures that our relationship will be sustained. This is a part of what relational sustainability is all about. So in the ontology, this is existence composed of intelligent, willful, sentient, attentive, and moral beings and forces. Respect and interdependence are crucial. Continuity of existence depends upon these relational principles of mutual benefit and reciprocal obligation. It is not theistic. It is relational in terms of what's going on. And it's not materialistic in the sense that I'm trying to accomplish some material outcome here. It is fundamentally spiritual and social in its dimensions. So the Tlingit habitus, as noted by several commentators through time, is that they will speak. Speaking to other entities is part of this affirmation. I'm going to skip down here to the third one. Accounts from the Tequedi clan who were referenced, for whom the grizzly bear is the primary crest, say that they were taught by grizzly bear to make intertidal stone traps by watching him catch salmon on the beach. It's not me seeing the holes, but the bear using the holes does what? They are teaching me. This is the habitus. This is the way in which things go forward in terms of how things are done. So this research that I'm going to comment on here has been done primarily in the west coast region of Prince of Wales Island, but I've also worked with the Huna Tlingit people, both of whose elders I thank very much and sincerely. And this embayment is an extraordinary location. I call it the Tlingit R&D Center in terms of what's gone on here over about 2,500 years. Now, we're looking at this aerial photo. That looks to most, well, this is a natural embayment. It's got two streams coming together. It's got an estuary. And so that's what it is. Okay, so when we encountered another part of it, when we encountered and went into this embayment in 1986, we were looking for the stone intertidal rocks that we saw on the outer part of the archipelago. But instead, we found something different. Buried beneath the muds and the silts are these kinds of stakes. And these kinds of stakes, in turn, form great intertidal structures. And in the context of those intertidal structures, we see enormous kinds of investments. This one here is about 1,500 years old. Every one of those pieces of wood is carved, and it comes out. And when you map all of those, each one of those little dots is an area of stakes, and that shows you the configuration. And there's a story that I can't go into about the historic change and evolution and development of what has happened in that location. So in terms of anti-hybridity, what we were able to do is pull together and understand that TLINGIT is not natural in the sense that it is unaffected by human activity. It is not the pure outcome of environmental processes. Its entire construct and form is a hybrid. It is a hybrid, and it is osmosis from culture, concepts, myths to nature. And that's what's gone on. This is an example of how, here too is another example, the KLAWOCK Estuary. is also, now that your eyes begin to be accustomed, this is for 100 years, fisheries biologists have walked across this landscape, and this has never dawned upon them that this might constitute. These are intertidal fish trap remains. This is a world, in my view, a world heritage site in terms of the ancestry of the Tlingit engineers and scientists that worked here. This is one part of it that can still be seen and worked on in detail today. It's at least 1,000 years old. In the estuary zone, we see these V finger-pointed islands. Well, there's some nice islands. Well, how did they come to be? There's an old-timer looking at and in fact demonstrating that those are created by intertidal wood fishing structures. There they are. They operate on a V principle. All of these structures operate on the principle of what I have, using dynamic nominalism, called tidal pulse fishing. You only fish on the ebb tide. They're completely inundated at high tide, which means what? Salmon can always go up. You only catch those that are coming back. That's what's called that. And this shows the kind of stakes that are there. There's that old timer again showing how those stakes all along there form the sedimentary context for the creation of those islands. Again, this constitutes hybridity. The ebb tidal pulse fishing is the way in which we move from myth to emotion to construct to the stream to the salmon and the sediment. All of that is a part of it. Ish is another central one which David Katsik helped us understand. And this is a deep pool. This is very important going forward in some of the future research. In Tlingit thought, this is a very important place in the stream as they watch salmon. And this is what an ish is. Any stream is a variegated dynamic of multiple kinds of contexts, which 4, 5, 10,000 years of observation Tlingits understood. There are the riffles where fish have to move rapidly, or the falls that they have to put up a lot of energy. But in the ish, they can relax and they can also spawn. They can regenerate, they can rejuvenate. And so it became sacred. This is one on the KLAWOCK River. This is one on the Neva River. And careful attention to that will reveal that that's not what you normally call, it's once again a hybrid, isn't it? It's a creation that is an intersection of concepts with the environment that is there. And here, more importantly, is another one. This is an ish that creates a pool behind it. And the manager of this particular stream said to me subsequently to my taking me, he says, Steve, next year the water was too low. I had to move the rock a little bit so the fish could get up. And then the next time I came back, he said, Steve, I figured out a way to let it be self-equilibrating so it can work no matter what the rainfall and the water level is. So this is a very important, that's what I refer to as a streamscaping. And this is where my dynamic movement in terms of new scholarship is going, to examine the degree to which in-stream habitats are, in fact, part of a network of conceptualization that implicate Tlingit myth and behavior. This is an example of the ish. Again, the ish spills over directly into the aesthetics. Here it's represented in these pools in the totem of Sokar. This is one of my favorite images of all. It's the representation of Ishkahit. What do we see the salmon doing in this particular case? What are they doing? They are all oriented towards the sacred place, to the sacred hole. It's a wonderful and powerful representation of the Basket Bay Tlingit people. There's another one. There are several of the others, these kinds of things that we can look at. This is called galseet, which means something. And here I'm looking for fish traps, okay? That's what I'm looking for. But along this particular circumstance are these rock walls. Well, that looks like a rock wall, but it's not by a stream. And salmon don't go by here. And there are some other things. My gosh, there's a whole bunch of them. And this is like a clam garden. We have these things now in southeastern Alaska. I'm not saying they suddenly appeared, but what? The lenses began to focus and be able to see in terms of these kinds of things. So in conclusion, there'll be additional research that we want to continue on, particularly some big questions associated with issues. And my extraordinary fortune and thanks to the Tlingit elders, the opportunities to be in place, to see things in place is absolutely essential. And so thank you all for listening to me. Like we're not on C-SPAN, but you can use the.
Thank you very much.
To acknowledge Steve for the acknowledgement of the words that he used, Tlingit engineers and Tlingit scientists. And it takes a long time for us to be able to begin to be acknowledged in that way. Because for thousands upon thousands of years, we have had a relationship with what you're talking about. It isn't something that we decided we were going to do, that we were going to take that as a topic or as a subject to study in school. We were taught this from our childhood and our relationship. All the things that you were doing, showing there, that particular thing, we failed to realize that what's happening is that the people were managing the resource. They were managing the resource by being able to identify the male from the female, as well as being able to, the escapement that basically is very important. Fish and game, fish and wildlife, and others are doing. So I just want to say thank you very much for your acknowledgement and recognition of the Tlingit people and their knowledge of the resource. Thank you.
Analyses.
Thank you very much, Steve. Our next speaker, I'd like to do a special introduction from my colleague, Dr. Rick Edwards. Rick has spent the last 12 years championing the topic that he's going to talk about, the terrestrial linkages with the ocean environment. Rick's training comes from a PhD at the University of Georgia and then some work in Australia. He's an aquatic ecologist by training, but he is a renaissance man when it comes to embracing other disciplines, especially soils and other strange things. So please welcome Dr. Rick Edwards.
Thanks, Dave. Well, good morning, all. Dave gave me a whimsical working title for this talk, and I kept it. And it got me on a whimsical contemplative thread. So I'm going to start off with a few words about boundaries and where we get our boundaries in science, and both the good and the bad that comes from that. In the Eastern and Western written traditions, going back to the Greeks and beyond, thinkers of big thoughts and philosophers have found it useful to partition the known world into 4 elements, sometimes 5, occasionally 6, but these 4 are kind of uniform among a number of different cultures: air, earth, fire, and water. And these elements were thought to represent both the physical world that we can see and the underlying spiritual world that had characteristics that were displayed by the elements that they chose. And the role of the celestial handmaidens there was to integrate the seen and the unseen and balance the elements among themselves and maintain peace and order in the cosmos. Well, that was good for the ancients. It's not a bad place to start. I'm a water guy, and as Dave said, I have an interest in soils, and earth, that's soils. So let's see what we can do with this. Well, the ancients lived in a simple world, right? And things are more complicated now. So fire, well, one box for fire just isn't going to do. This is the Forest Service. We deal with fire a lot. So there's different kinds of fires we have to deal with, different boxes we have to draw with different boundaries. And well, that's not enough either, because we can subdivide those boxes in ever-increasing and smaller complex boxes. Well, I'm not a fire guy, I'm a water guy, so I can play this game. Whew, watch me go. And this is just the first start. I ran out of room for all the boxes I could put water in and all the boundaries I could draw about them. This is called reductionism, and it's been a very powerful tool in Western science, but it comes at a cost. One of the costs is once you do this, and rather quickly, you end up with embarrassing and unsightly overload of boxes, where each discipline, each way we see the world is broken into smaller and smaller boxes with more and more specific boundaries. And that creates some problems. one, you quickly run out of celestial handmaidens. There's not enough to balance all those boxes on their heads. And I personally think I see evidence that the cosmos is lacking in balance and harmony these days. But there's a more prosaic drawback to this, is each one of those boxes, those ever decreasing in size boxes, is associated with an ologist or an expert. And we know that experts are people who know everything about nothing, right? Or a group of special interest associated with it who are very vocal in promoting the interest inside that particular little box's boundaries. And sometimes in the course of doing this, it's a very powerful thing. Don't get me wrong, I'm not dismissing it entirely. It's been a very powerful way to carve up the natural world so we can understand and categorize our knowledge. But one of the drawbacks is we forget that all these boxes are connected by flows and arrows, some more than others, but all of them are connected. And when we go back to our office and get involved in our everyday activity inside that little box, even though we may recognize in our own hearts that this is just a part of a greater whole, it becomes very difficult to step back and think about what happens, what new insights we get when we connect the boxes and draw the boundaries differently. So the rest of this talk will basically be to support the idea that the coastal temperate rainforest, the perhumid coastal temperate rainforest, I'm drawing another box, only in modern life, a box is a polygon, right? That's the GIS-based box and boundary that we hem ourselves in with. The coastal temperate rainforest is one of the worst places on Earth to let ourselves get caught up in this little box way of thinking. And it gets even worse because we subdivide those little boxes into bigger boxes. And, you know, there's the USA box and the Canada box. And people have mentioned the fact that our maps, the Canadian maps leave out Alaska and the Alaska maps leave out Canada. Then we have the agency boxes and we have the municipality and government boxes and so on and so forth. And we recognize this is a problem. President Obama in his State of the Union address made a joke about the fact that there are two different federal agencies that manage salmon, one when they're in the ocean and one when they're in freshwater. He neglected to mention that many of those salmon actually have dual citizenship and cross the international border without passports or without filing a customs declaration. So I think we need to bring Homeland Security in on this as well, and we'll have three agencies managing it. Okay, so let's bring this back to place. Where are we? We're in a temperate rainforest, and it's a maritime forest. Well, what does that mean? So let me just throw out some superlatives here. And having just dismissed the utility of boxes, I'm going to give you data that come from subdivided boxes. Some from the Tongass National Forest, which is a box, some from British Columbia. Happily, the ACRC is actively engaged in this transboundary integration of data. And so someday I'll be able to get up here and give you statistics from the integrated box that ranges across the international boundary and encompasses all the coastal temperate rainforest. But the Tongass alone contains about 29,000 kilometers of coastline. That's about 20% of the coastline in the entire United States. There's an additional 25,000 kilometers of coastline in British Columbia. The island archipelago that comprises the Tongass is about 35,000 square kilometers of estuary. And that's the part in Southeast Alaska alone. There's somewhere between 10 and 15,000 streams in the Tongass National Forest, exclusive of the transboundary rivers. It's an unknowable quantity, but it's somewhere in that range. For every square kilometer of tropical rainforest in Southeast Alaska, there is almost half a kilometer of shoreline associated with that. This is a maritime forest like no maritime forest I've ever seen or experienced. Maybe the biggest one in the world, I don't know, because those are different boxes and I couldn't get the data. But generally we think of maritime forests as this fringe that's affected by the salt spray on the vegetation. And so I think maritime forest maybe doesn't do justice to what kind of forest we have here. And another factor of this is with these thousands and thousands of streams, they're small, they're short, and they're steep. And the streams don't get a lot of time to work on the water before it's discharged into the estuary. And so the concentrations of materials in that water are higher than the concentrations of materials, say, in the Yukon, which is discharging a lot of water, but has days, weeks of time to work on that water before it's lost to the ocean. All right, so let's start with something we all know. This is a system. This rainforest system is a coupled system comprised of a terrestrial box and an aquatic box. And that aquatic box is comprised of an ocean box, an estuary box, and a stream and lake box. So we all know about the marine inputs, one of the flows between those boxes. And nature laughs at our puny little attempts to put it in boxes, right? Materials, animals, energy flow across the boundaries of these open ecosystems with no reference to what we would like to do to order them. So we all know about the marine-derived nutrient subsidy, or sometimes called the salmon-derived nutrient subsidy if we're only talking about the salmon and not the hooligan and the herring. There are about 30 million salmon a year that return to spawn in the streams. This is not the total run size, this is the escapement. This is what we let get by us and go back up into the natal streams. It's an enormous amount of material, about 8,000 metric tons of carbon, a couple thousand metric tons of nitrogen, and less, but still a significant amount of phosphorus. It's not just carbon, right? It's food, it's fish, and the flow of salmon-derived nutrients into primary or secondary consumers is one of the things that makes this place what it is. It makes it unique and makes a million people want to come see it. There's also a more hidden flow of those primary nutrients into the vegetation adjacent to the spawning streams, and that's come to be known as the salmon in the trees hypothesis. I personally think the generality of this is a little exaggerated, but unquestionably it happens sometimes. By the way, those aren't salmon in the tree, those are salmons in a root wad, but that's as close as I could get. All right, let's talk about the terrestrial outputs. This is a reciprocal exchange, things returning from the ocean back to land, things moving from the land out into the ocean. There are gigantic amounts of water that move out of this region into the Gulf of Alaska. Here's a map that I adapted from one Aaron Hood created, just showing the relative discharge of these areas. The Mississippi River discharges about 530 cubic kilometers of water a year. The Gulf of Alaska rivers, including the Transboundary rivers and all the rainforest rivers, discharge about 870 cubic kilometers of water a year. All right? The coastal rivers alone discharge more than the entire Mississippi, and the Tongass National Forest rainforest rivers, not the Transboundary, not the big rivers, alone discharge 200 kilometers of water a year, roughly equal to the discharge of the Columbia River or the Yukon River, which have basins that are an order of magnitude larger. This is what happens when you live in a rainforest. This water moves through soils that contain some of the highest concentrations of organic matter and carbon anywhere in the world. The Tongass alone contains about 6% of all the carbon in forests in the United States. This very rich soil is saturated with water. We have abundant wetlands. The water leaches some of this material out, and it flows out into the estuary and the ocean. This is just a little cartoon about what might happen to carbon when it goes out. So let's talk about that a little. The flux, the area-weighted flux of organic matter, dissolved organic carbon out of the Tongass into the estuary is the highest ever measured in the world. It's orders of magnitude higher than most systems, higher than tropical rainforests. So let's think about that. If we look at the Tongass alone, it's exporting about 8 teragrams of carbon a year. If we scale that up to the entire per-humid coastal temperate rainforest, including British Columbia, that's about 1.5. How much carbon is that? Teragram is kind of a meaningless word. Well, that's equivalent to taking 3 billion board feet of trees a year off the land and sending that to Japan. Those of you that are more oriented around commerce, it's equivalent to framing 190,000 houses per year. Or if you're one of those human and social people, the combined population of Canada and the United States is something like, 340 million people, somewhere around there. If 1/3 of the population of the United States and Canada got in a canoe and paddled out into the Gulf of Alaska, never to return, they would be moving the same amount of carbon as the streams do on an annual basis. How am I doing for time? Okay, so let's compare what the forest is feeding to the estuaries in the ocean, okay, with what the salmon are bringing back in. And I do this not to diss the salmon, all right, because the bears need those salmon. I do this just to show that in our little boxes, ignoring these big flows and these reciprocal exchanges, we've missed a really important story there. The rivers are providing to the ocean and the estuary 100 times more carbon than the salmon bring back. And it's roughly 25 times as much nitrogen and phosphorus. And it's not just those, it's iron, silica, potassium, calcium, and so forth. So there's this huge mass of labile carbon going out into the marine system. Let's think a little bit about what this might be doing. This is from a recent review paper looking at fluxes of carbon dioxide across the air-water interface, averaged around the whole world. And what we see is, although estuaries are a tiny slice of the pie there, they are exporting more CO2 to the atmosphere than the ocean and the continental shelves that are actively taking it up. Well, let me just show you something here. These are the data points on which that worldwide model is built, and you'll notice a discrete absence of any data from this part of the world. Given this huge flux of carbon and the fact that we know that at least a portion of it is actively metabolized better by heterotrophs in the estuaries, we can guess that this model may not apply very well to this part of the world, but it's certainly an interesting question that we should pursue. Okay, that's the metabolism of the labile organic part of that. What about the effect of the other things dissolved in that water? The distribution of productivity around the world is not even, and it tends to be disproportionately more productive up here in the north. If we look on the west coast of the United States, we see little centers of productivity. Down south, a lot of that productivity is created by upwelling of nutrient-enriched marine waters into the euphotic zone. When we get up into the Alexander Archipelago, it gets very interesting. On the right side, that's sea surface chlorophyll concentrations in the summer. All right. Now, there are some problems with these kinds of plots, but what you see is this estuary lights up. It's a very productive place, and we know that. There's a $5 billion fishing industry in Alaska that's partially supported by the productivity in here. On the left is a plot of the concentration of carbon coming out of those watersheds. In this case, the carbon can be an imperfect tracer for outputs from the forest soils. There's a number of questions we can ask about this. But the point I want to make here is we have reason to believe that some proportion, and I would guess a large proportion of productivity in this estuary is driven, is promoted by this outwelling of terrestrial nutrients from the soils. Does it stop there? No, it does not stop there. This is a picture of chlorophyll concentrations in the nearshore coastal waters. And what you see, do I have a pointer here? See those little swirly blebs there in the middle of the picture? Those are called the Haida, Sitka, and Aakw'taatseen eddies. About this time of the year, all the fresh water that's built up and the nutrients and the phytoplankton in that water start to bubble off and get entrained in the currents in the Gulf of Alaska that they partially create. And you can track these things by satellite. They're anticyclonic vortexes that float out and persist for years, 4 or 5 years. In the upper left there, you see a picture of sea surface height anomalies that show you these bubbles, and they line up like cars in a freight train and move out into the ocean. In the lower right, there's a picture of what one of those cross-section looks like. It's a mixture of freshwater and saltwater and all those nutrients, and because it's less dense, it sits up about this much higher than the surrounding marine waters. And during the cruise that these data were taken from, about 50% of the surface chlorophyll in the Gulf of Alaska was contained within these eddies that only comprise 10% of the total surface of the Gulf. I would submit that this is evidence of a terrestrial influence on marine productivity 500 miles away from shore. We're not used to thinking in this term when we think in our little boxes. Okay, briefly, climate change is coming. It looks like we're somewhere on the side of a bullseye of a target for warming. What we know about all these 10,000, 15,000 watersheds is they're not all the same. We can break them into 3 different categories, and if you look at that top figure there is when the water comes out of those seasonally across the year. At present, the differences in the annual discharge in the glacial watersheds, what we call the snowbelt watersheds, and the lower watersheds that don't store a lot of snow that we call the rainfall watersheds tends to even out discharge out of the forest into the estuary. Each one of those also has its own personality. As you look down, temperature, dissolved organic carbon, phosphorus. Each one of those watershed types is pumping out water of a different chemical composition at a different time over the year. As the climate warms and the snow line increases and the glaciers melt and the snow goes away, we're going to see tremendous differences in the timing and amount of water that comes out into the island archipelago. I saw a talk yesterday, I've forgotten who it was, that talked about this productivity burst in icy straits when that water comes out and mixes with the upwelling seawater. The nature, the magnitude, and the chemistry quality of that water is going to change dramatically as warming continues. And we really don't know what the effects of that are going to be. We need to think outside the box. We need to recognize these exchanges and flows. There are a number of questions, and I won't belabor those because I think I'm running out of time. But with Kirk's talk yesterday, I came back with a serious case of Ray Troll envy. You know, he's got Ray Troll drawing his figures. How unfair is that? So last night I did a little quick Googling. And with apologies to Ray, I'd like to finish up and say that there are different ways to see the world. And David Katzek has opened my eyes in the last 2 or 3 weeks in our interactions to tell me that the way the Greeks saw the world is not necessarily the only way. And it's not even the most appropriate way in this part of the world. And the Tlingit scientists and knowledge bearers had a different way of relating to the land and seeing these relationships. And I think we can learn from them. And I think once we start to pull these things together and look across boundaries and understand these interactions, we can expand our concept that there are salmon in the trees and also recognize that there are certainly soil in the salmon as well. Thank you.
Got time for one question?
You must go to the microphone, though, otherwise people online will not be able to hear.
Any questions for Rick?
Boy, that's unusual.
You did a great job.
Thanks, Rick. Our next speaker is Jim Chu, and he's going to talk about a subject near and dear to my heart, the migratory birds that populate our land and then go provide an intercontinental exchange.
It's Gretchen.
Oh, is Gretchen next? I'm sorry. I apologize. Gretchen Harrington is going to talk about another thing that I enjoy and we've heard a lot about, the salmon populations. Gretchen's a NEPA coordinator for NOAA Fisheries of the Alaska region. She has over 14 years experience working on cross-jurisdictional issues and cooperative management for fisheries as diverse as the Bering Sea crab fisheries, scallop fishery, and salmon fisheries. Her talk today focuses on salmon fishery management in federal waters off Alaska and reflects her experience as the project lead for the ongoing action to comprehensively revise the fishery management plan for the salmon fisheries in the EE zone off the coast of Alaska. Please welcome Gretchen Harrington.
Hello, I'm Gretchen Harrington, and thanks for that very nice introduction. Whoops. There we go. So I'm going to talk about, we've heard a lot about salmon this past couple days and how they interact with the terrestrial environment, nearshore environment. I am going to talk about what we do when salmon are in the ocean environment. And you know, the goal is to enable salmon to be managed seamlessly throughout their range. In an environment where we have state waters, federal waters, we have transboundary stocks that migrate from Canada into US waters and vice versa, and also endangered stocks that need to be protected. So we have a federal salmon fishery management plan that covers the entire EEZ off Alaska, which is the exclusive economic zone. It goes from 3 miles out to 200 miles out. And as you can see, this is a very large area. The salmon FMP is divided into the east area and a west area at Cape Suckling right here. And the salmon FMP is unique in that in the west area, it pretty much closes all commercial fishing in the EEZ, with a couple of exceptions, and I'll talk a little bit later about what led up to that. So there's no commercial fishing for salmon in the EEZ off Alaska well, there's not really salmon in the Arctic, but all of this area is closed to commercial salmon fishing. And I'm going to focus today's talk on the east area, where the only commercial salmon fishing in federal waters is the Southeast Alaska troll fishery. And all 5 species of salmon are covered under the FMP. So fishery management plans are a product from the Magnuson-Stevens Fishery Conservation and Management Act. And the Magnuson-Stevens Act established the 8 regional management councils. Our council is the North Pacific Fishery Management Council. And the Magnuson Act charges the councils to develop and recommend to the Secretary of Commerce fishery management plans. And fishery management plans, it's important to remember, only apply in federal waters, so that area outside of 3 miles. The Magnuson Act requires that all management actions comply with 10 national standards, the most important of which is National Standard 1, that to prevent overfishing while achieving optimum yield from the fisheries. The Magnuson Act also contains 15 required provisions that all FMPs have to have in them. For example, essential fish habitat. The most recent requirement was for annual catch limits. Another primary one is each FMP must have criteria and methods in order to determine whether or not a stock is overfished or experiencing overfishing. For salmon, and actually for crab and for scallops, there's also a provision in the Magnuson Act, which is a relatively recent one, that allows FMPs the ability to delegate management to a state. And that allows the state to regulate a fishing vessel outside the boundaries of the state as long as the state's laws and regulations are consistent with the FMP and the Magnuson-Stevens Act, which includes the 10 national standards. So there's a little bit of a balance there between the required provisions of a fishery management plan. These are things that must be in the plan, and then the ability to defer management. So the salmon fishery management plan was one of the first. It was, I'm sorry, not that way. Okay. The salmon fishery management plan was one of the first. It was first approved in 1979. And at that time, and it's interesting to go back and to look at that management plan and the documents that were created at that time, because a lot's changed, but it's amazing how much has remained the same. The primary management measure at that time was to limit entry into the commercial troll fishery in Southeast Alaska. So again, in that east area. At that time, the state of Alaska was developing the Commercial Fishery Entry Commission and the limited entry permits. And the concern was if there was a state limited entry system without a complementary federal limited entry system, effort would increase in the EEZ waters. And so in order to have a complementary system in federal and state waters, we created a federal limited entry program that kind of went away over time. Also in this FMP, most of the other management measures for the fishery were equivalent to the state of Alaska measures, which really was kind of burdensome because every time a season opened or closed or size limit changed or that type of action, the federal government had to change its regulations when the state changed theirs. Our system is slower, so there was always this kind of disconnect. Also, at that time, there was no ability in the then Magnuson Act to delegate management to the state of Alaska. So In 1990, the North Pacific Fishery Management Council looked at the FMP again and decided to comprehensively revise the FMP. A lot had changed between 1979 and 1990. There was this ability to delegate management so that the state had the ability to open and close fisheries, set seasons and areas and gear, all those types of fishery regulations. And also it recognized the Pacific Salmon Treaty and the role of the Pacific Salmon Commission in the 1990 version. Let me just make sure I'm... this 1990 version also included since 1990, we've amended the FMP a couple times to include essential fish habitat. So we've defined essential fish habitat for salmon throughout Alaska, and status determination criteria to determine whether or not the stocks were overfished or overfishing was occurring. And part of that was a lot of working with ADF&G to make status determination criteria that fit the national guidelines and the national requirements, but that also made sense for salmon and the way salmon are managed. And that was a very collaborative process to accomplish those. So we have them now. And then right now the council recently recommended another comprehensive revisions to the salmon FMP, and they took final action in December 2011. For Southeast Alaska, we've updated the FMP. We've added new requirements such as the annual catch limits, addressing annual catch limits, but the FMP is fundamentally the same. There were some changes in the west area that I'm not going to go into today, but currently the revised FMP is available for public comment, and under the Magnuson-Stevens Act, when a council recommends a fishery management plan to the secretary puts the plan out for public comment. Then at the end of the comment period, decides whether to approve, disapprove, or partially approve the FMP or FMP amendment. So just a little bit of information about the Southeast Alaska troll fishery. It's the primary fishery in the salmon FMP because we've closed the rest of the EEZ to fishing. And the FMP recognizes that the federal waters component cannot be managed in isolation from the troll fishery in state waters and all other salmon fisheries. The state of Alaska does a very good job looking at salmon comprehensively and all sources of fishery removals. And so the FMP delegates management to the state, and the council has set forth the management goals and objectives and addresses each of the 15 required provisions in the Magnuson Act in an FMP, but it does so in a way that allows the state to manage the troll fishery. It's just a little bit of background. The troll fishery primarily targets Chinook and coho. Troll gear works by dragging baited hooks or artificial lures through the water, and there's two seasons, a winter season and a general summer season, which is divided into two fisheries, and it's the summer fishery that occurs in EEZ waters. So you see we're talking about a small piece of a larger whole. And just to give you an idea of the, this is catch data just for Chinook. This is just an example looking at the total Chinook catch in the troll fishery, the amount of Chinook caught in the last 5 years through 2010 in the EEZ, and the percentage. And the average percentage, 9.3% of the troll catch of Chinook occurs in federal waters. So one of the important things for the management of the troll fishery is the fact that some of these Chinook they're transboundary, so they can originate in Canada. And in 1985, the U.S. and Canada signed the Pacific Salmon Treaty for the cooperative management, research, and enhancement of Pacific salmon. And this addresses the conservation and allocation of Pacific salmon stocks that originate in one country and are subject to interception or harvest in another. And so here's a map that has both the US and Canadian waters. I know that's been an issue. So we're talking about a fishery that occurs, the troll fishery occurs up here, but the Pacific Salmon Treaty has divided the Chinook management into regions: Southeast Alaska, North Central British Columbia, west coast of Vancouver Island, and Washington, Oregon, and Idaho. And so, and the way they implement this treaty, or the way that they ensure that overfishing is prevented and that transboundary stocks can return to their country of origin, is they set a limit, a total harvest ceiling on the annual number of Chinook that can be caught in Southeast Alaska. So the treaty requires that the US and Canada conduct their fisheries to prevent overfishing, again, like the Magnuson Act, and ensure that each country realizes the benefits from salmon that originate in their waters. And the Pacific Salmon Treaty establishes the Pacific Salmon Commission, and they use the best available information to determine the annual harvest ceiling. And then the state of Alaska manages the sport commercial fisheries under the harvest ceiling and allocates the catch to the different fisheries following the guidelines from the Alaska Board of Fisheries. So, and this is one of the interesting things in trying to go back and look at the history of the Salmon and Fishery Management Plan, is that there are another couple of international laws that I think are pretty unique to salmon and pretty interesting. So there's the International Convention for the High Seas Fisheries of the North Pacific Ocean. That was from 1954 to 1992, and it was replaced by the Convention for the Conservation of Anadromous Stocks in the North Pacific Ocean. And this international convention closed the high seas to salmon fishing, including, so in 1954, that was before we had what we now call the EEZ, before we had the waters under the jurisdiction of, before we had the Magnuson Act. So it closed those waters to commercial fishing with nets, but the state could maintained control over what was called the territorial sea, which was 0 to 3 miles. So there are three net fisheries that occur in EEZ waters in the west area that have been allowed to continue since 1954, and that's the Cook Inlet, Copper River, and Alaska Peninsula. So and then in 1992, the Convention for the Conservation of Anadromous Stocks in the North Pacific Ocean, that was after we had established our EEZ, and that convention only closes the high seas, international waters outside the jurisdiction of the member states. And for that, I think it's the US, the US, Russia, Japan, and Korea, off the top of my head. So the FMP, when it came into place in 1979, maintained the original prohibition on commercial fishing with nets from the 1954 convention. So then we get to the Endangered Species Act. The other thing that when we're putting this all together, we must keep in mind, and that is for the Endangered Species Act, as you probably all know, there are no Alaska salmon listed under the ESA. However, there are 28 ESA listed salmon stocks, and I'm just calling them stocks as a shorthand, that originate in freshwater habitat in Oregon, Washington, Oregon, Idaho, and California. So 11 of these ESA salmon stocks, and that includes the 5 species of either Pacific salmon or steelhead, that are thought to range into the marine waters off Alaska during their ocean migration. And as you know, in the ocean, these ESA-listed salmon stocks mix with salmon from Alaska, British Columbia, and other areas where there are healthier salmon populations. So the FMP is the federal nexus for the ESA Section 7 consultation. So under the ESA, the federal government can't take action or should not take action to jeopardize the continued existence of an ESA listed species. And so we conduct a consultation to make sure that the fisheries that we authorize under the FMP are not likely to jeopardize the continued existence, and that also we issue what's called an incidental take statement, which is basically saying we understand that some listed species may be caught and that's okay. Because and so in 2008, NIMS issued a biological opinion that included no jeopardy for the fishery, and then included an incidental take statement that covers the Pacific Salmon Treaty and the deferral of management to the state. So, you know, one of the theme for this session has been how to look at boundaries, how to address them, and they're very, especially in management, just like in the natural systems, they're very real. And it's important when you're looking at management to make sure that the management is appropriate to the biology of the species. And I think for salmon, where we have some very real goals and objectives, such as the Magnuson Act and things like that, that we also keep in mind the biology of the species in designing how we're going to comply with our obligations while appropriately managing the salmon. And part of that is understanding the institutional frameworks, what's involved, understanding the pieces as well as the whole, and that I thought the boxes example in the previous talk was a very good one, because you need to know both. You need to know each box in detail, but you also need to understand the whole and how it all fits together. And it requires a lot of collaboration, which is recognizing that no one person is the expert, and that the success requires the collective expertise of a number of people. And that is borne out even in coordinating a project such as this, the amount that you need to work with different people, because it just requires expertise in a number of different disciplines. And then communication, open and often, and putting it in writing. I think that's also a major key, because everything needs to be documented and clearly explained how things fit together and how things work. And I think that one of the pieces to that includes both internal communication, so communicating with your colleagues in your team and creating a team environment, but then also external communication. What are we doing and why, and how it all fits together. So that concludes my talk. I just have a slide on the photo credits, and thank you very much.
All right, thank you, Gretchen. I'll make sure I sign. So thanks very much. So our next speaker, Jim Chu, it'd be interesting if he explored the 6 or 7 federal regulations that covered kittiwakes. But I think we're moving from the highly regulated salmon fishery to the really interesting transboundary migration of birds. And we're really pleased that Jim can make time to join us. So Jim has worked for the U.S. Forest Service for 32 years, and for the last 7 years, he has worked with the international programs of the U.S. Forest Service in the Wings Across America program. Jim currently manages the Copper River International Migratory Bird Initiative, also known as CRIMBY, a project to connect communities with birds that they share. Please give a warm welcome to Jim Chu.
Thanks very much. I'm pleased to be here today. Also would like to thank the folks on the Tongass and the Chugach and the regional office for allowing me to be part of this great initiative. So thanks to you all. Today I'm going to talk about the CRIMBY initiative, and we'll talk about the Copper River Delta, which most of you probably know about, so we'll go through that rather quickly, and then we'll talk about some of the work that we've been doing with some of our partners. So the Copper River Delta is located in the Chugach National Forest, second largest national forest in the system. The delta itself is a 700,000 acre wetland, and it's the largest contiguous wetland on the Pacific coast. Over 200 species of migratory birds are found on the Copper River Delta and the Gulf region. And up to 5 million shorebirds come during the spring migration. Almost 90% of the western sandpiper and almost 100% of the Pacific dunlin come here during migration. So here's a map of the key stopover sites, and you can see Stikine is also listed. And so we've been outreaching to folks in Stikine and working on the Tongass and the Aakw'taatseen as well. Boundary Bay is not on that list, and I've got to figure out how to put that on there, but I'll figure it out eventually. The history of Crimby, the initiative began in 2001 with 6 charter members, international programs of the Forest Service, Ducks Unlimited, and also Ducks Unlimited of the Western region, the Western Boreal Forest Initiative in Canada, the Alaska region of the Forest Service, Pacific Northwest Research Station in Portland and also in Alaska, and the Chugach National Forest. And the initiative began when folks from these different agencies and groups got together, and over a few malt beverages, they said, you know, we're not seeing as many shorebirds here as we've seen in the past. We need to be looking north and south of the U.S. border to do something about this. So over time, the initiative has added Region 6 and 5 of the Forest Service, which include California, Oregon, and Washington, the Tongass National Forest, Calidris in Colombia, Aves de Conservación in Ecuador, Pronatura in Mexico, Bird Studies Canada, Fish and Wildlife Service, and then Panama Audubon Society more recently. The mission statement: to strengthen conservation of the Copper River area's migratory bird resources through effective international partnerships and action on the ground. So the people who started this initiative really wanted to see action in the ground. They wanted to see something happening both north and south of the U.S. border. So the goals: strengthen conservation of migratory birds through existing initiatives and plans, and there's water bird plans, there's waterfowl plans, shorebird plans, waterbird plans. So lots of plans that we want to try to tier to. We don't need new plans, we just need to start using some of the existing plans. Strengthen the knowledge base for migratory bird conservation by initiating and facilitating priority research needs and assessments. Build new and stronger partnerships for migratory bird conservation, including Latin American NGOs and governments. And finally, increase public understanding and appreciation for migratory birds and their associated ecosystems. Cultivate community involvement and foster public support for achieving conservation of migratory bird diversity. So why Crimby? Our investments in the United States must be protected through our work internationally. Because we're dealing with migratory species, it's not enough just to manage your piece of land and do things that you want to do there. You've got to look north and south of the border. So we're trying to make investments in those places. Although we caution our partners, we're not a granting program like U.S. Fish and Wildlife Service. We have very limited amount of funds. What we are more about is building relationships between communities and agencies. Conserving birds that use the Copper River Delta can be done more effectively through the development of international partnerships, using and expanding that big tent idea. So getting everybody under the same tent and looking at shared goals and mutual interests. Shorebirds face an uncertain future, and everyone likes birds. We see that time and time again. So I want to talk a little bit about what we've been doing in Mexico, and we helped with development of a shorebird conservation plan in Mexico, developed a link between the municipality of Angostura, Mexico, and that is an area right adjacent to Bahia Santa Maria, one of the key shorebird areas in Mexico, with Cordova, to strengthen conservation efforts and assist in developing an Angostura Shorebird Festival. Identify additional wintering and staging habitats and assisting in developing conservation strategies. So the Mexican Shorebird Plan, Forest Service, Ducks Unlimited of Mexico, CMRNAT, which is kind of like Fish and Wildlife Service in Mexico, and then Ducks Unlimited in the United States. We're all partners with this project. So the vision for this plan represents for Mexico the third in a trilogy of country-level conservation plans for North America. Development and integration of Mexican shorebird conservation plan with existing plans for Canada and the United States is timely and critical. So the strategy, during the strategy and the development of the plan, they held 1 general meeting and 6 regional meetings. Participation included 60 professionals from more than 40 organizations in the process. This was a huge effort. This was probably 2006, 2007 when this took place. This was huge because a lot of times people in these groups didn't like to play in the same sandbox. And so to get them at this meeting to commit to working on a shorebird plan for the whole country was really cool, and it worked. 62 sites of importance for shorebirds were identified in Mexico, and the plan is helping to decision-making and will eventually guide conservation projects. And this is happening, and I'll address that in a couple of other slides later on. So here are the 27 priority wetlands for shorebirds were identified. You can see along the northwest coast of Mexico, that's a high area of shorebird concentration in wetlands, so we'll be talking about that shortly. So the use of information, different committees have been established to deal with wetlands and mangroves and conservation in Mexico. The plan was rolled out, I think, in 2008, 2009, and it was adopted by the government, and it's being used, and it spawned some additional work in Mexico. So I want to talk about international community-based partnerships. So one of the things that we've managed to do is bring some of our partners up to Cordova, Alaska, and also to Wrangell to see the habitat. The same birds are flying from Latin America all the way up to Cordova and up to Alaska. So we always bring them up during the Cordova Shorebird Festival, which is kind of cool because they get a chance to see lots of people looking at birds. So there's a list of folks that we brought up, and I just want to highlight the mayor of Angostura, which is adjacent to Bahia Santa Maria. And on the left, you can see Mayor Tim Joyce, who's also in the audience here, shaking hands with the mayor of Angostura. And so we're out in the Copper River Delta, and he sees all these western sandpipers, and he said, you know, we have the same birds in Mexico. I said, yeah, we know. They've come from Mexico to Alaska. And he said, and people come and pay to see them? Yes, they do. So that helped spawn an effort to try to get some ecotourism opportunities in Bahia Santa Maria and Angostura. Unfortunately, Angostura is located in the state of Sinaloa, which is one of the more dangerous states right now, so we've kind of put those efforts on hold, but eventually we hope that people from the United States and other places can go down to Bahia Santa Maria and see shorebirds down in Mexico, because it's a pretty cool site. And on the right, you can see the 2 mayors signing an agreement between Angostura and Cordova to protect migratory bird species and encourage tourism and related activities. I think this trip really had an impact on the mayor of Angostura. Tim gave him the key to the city, which he was greatly appreciative about. Then he noticed it was also a bottle opener, so that was even cool. But what it did was it got the mayor of Angostura thinking about conservation. And so after that time, he was very dedicated in helping ProNatura, our partner down there, with conservation efforts. So when the mayor from Angostura came up to Alaska, he was accompanied by a couple of guys from the local TV station, Channel 8, I believe it was. And it's a for-profit station, but they were really interested in conservation. So they would do they had a television program called Reflecto Sinaloa, and so they dedicated 3 of their programs about the Alaska trip. These are like 10 or 15-minute programs, but they air on for-profit television to show the linkages between the shorebirds in Santa Maria Bay and other parts of the state with Alaska. And the event that you're looking at there is a trash cleanup day on one of the islands in Bahia Santa Maria that's used by fishermen, where they just leave their stuff there. And so the city council of Angostura, as well as the mayor and the TV channel, is out with school children picking up trash. And in the background, I think you can see a sign there. It says, "Please don't litter, the impact on birds." And one of the logos on that sign is the U.S. Forest Service, because we are a part of that. And the people in Sinaloa understand this connection between shorebirds there and Alaska. So I want to talk a little bit about some of the other programs in Mexico that we've been a part of. Let's see. So I'll just run through these briefly. I'm not going to talk about the specifics of the project, but I just want to mention the projects. So shorebird surveys of Bay of Colorado and Baja, or in Mexico. And in yellow are the partners that were involved in the project. Characterization of patterns of habitat use of wintering western sandpipers in Ensenada Pabellones Bay in Sinaloa. shorebird breeding surveys in northwest Mexico, shorebird recovery project in northwest Mexico with Western Hemisphere Shorebird Reserve Network and other partners in northwest Mexico. And I think that these projects were a result of that Mexican shorebird plan. Some of the people in northwest Mexico felt they needed their own plan, so they actually formed a group and they followed up and they developed their own regional shorebird plan for northwest Mexico. And these are some of the products that came out of that plan. So I think the results of these projects were that we now have a better knowledge of the bird distribution in northwest Mexico. We've identified some of the key threats in these local areas. And we've also even had the government declare that some of these species should be listed as sensitive as a result of this work that's been done. One of the other things that we've been involved with for the last 2 or 3 years is an international biologist exchange. This is the project that came about because Aaron Cooper in Cordova said, I'd like to bring up some biologists so they could work up here on the Delta and we could learn from them as well as them learning about some of the things that we're doing. So the first year we had one of the biologists from Calidris come up from Colombia. And I want to state that these are professional biologists who have regular jobs with their organizations, but the organization allowed them to come to Cordova and work in Cordova because they felt it was that important for them to see the connection between these areas that we share, the birds that we share and manage, the areas that we manage. So I think that Carlos had a pretty good summer, wouldn't you say? And he also had a chance to go down to the Tongass and work in Wrangell, as well as work with Rick Langto with the Fish and Wildlife Service. And last year we followed that up with a gentleman from Pronatura from Mexico, and he came up and did the same thing, but not for as long a time. And I think he also had a pretty good experience. But it's these kind of relationships and sharing that we can do to, we've got partners that know what we do in Alaska, and it's our hope that we'll be able to bring some folks from Alaska down to these areas and work down there for an extended period of time. Next, I want to talk a little bit about some education and outreach projects that we've been doing. Winging Northward is the project. It's an electronic field trip. It's a partnership between the Forest Service and Prince William Network. And it was started by Sandy Frost up in Cordova at the time. So it was geared for 4th through 8th grade students. And it's an interactive education program based on the website. And it's interactive because it allows students to ask questions after the program is over. So we had, for the first program, there was a hub in Prince William County, Virginia, and the reason they got involved in this project is that they have a 24-hour-a-day television station, and their guys like to do programming, and so they thought this would be kind of cool to have this education for youth. And so there's with this project, there was also a website that was developed, and there's information that's housed on the website. There's curricula that's developed, and it's still there. So people can still go to it now and find this program as well as a couple of other programs that I'll talk about. So this was the first one that was done in 2002. And when I was hired for the job in 2004, 2005, whatever it was, the first thing Dan Logan told me was that he wanted me to do another one of these programs because it was so successful, he wanted us to do another program. So because Dan told me to do it, I did it. So in 2006, 2007, we expanded the Winging Northward program and called it Migration Science and Mystery. It included live television broadcasts, webcasts, or chats with scientists in Panama, Mexico, the United States, and Canada. And we reached over 500,000 students with all the different broadcasts. And although this program was geared for students, it's more than just an education program. What it took to get these programs done was meetings and visits with the local, education officials in these different countries, with government agencies, and so we were able to build trust with the different folks there, and the hope is that we will have lifelong partnerships with the groups that we're working with down there. And if you go to the website, you'll see this program as well as some of the others that are there. So the goals for the Migration Science and Mystery include appreciate that migratory birds are shared between different communities throughout the migration routes. Understand the role of citizens, public land management agencies, and non-governmental organizations in protecting and conserving habitat. Become motivated to take action in their own backyards and protect birds and their habitats. And this is one of the key messages. Not only do we want you to learn, we want you to do something about it. So I think that's a real good take-home message. And we were fortunate to get funding from Alaska, from the Forest Service Region 10 to do this project. I think we received $30,000. And I think it was the aspect of taking some action in your own backyard really made a difference. So now in 2012, we're going to do another program called Wetlands Live, and it will be coming to a station near you in fall of 2012. So this program will focus on the water resources within the Pacific Rim. We'll be connecting sites using shorebirds and salmon/fish as ambassadors. We'll have links to climate change in this program. We'll do 3 programs, and we're still developing the content right now. So what is a wetland and why are they important? How are wetlands in the Pacific Rim connected? And having youth in action will also be a key component. So lastly, I want to talk about a project called Range-Wide Shorebird Survey. So this project came about a couple of years ago when my boss and one of the partners from ProNatura said, we should do something that really links our different groups together. We should do a range-wide shorebird survey project. And so they said, Jim, do this. And so about 2 or 3 months before my performance appraisal, I said, geez, I better do something. So I started looking through the emails that I had received from different groups about some of the things they were doing, and I happened to see one from PRBO, Point Reyes Bird Observatory, and they were doing a wintering shorebird survey in the state of California, and they had funding for that. So I asked them to send me some information about that survey, and then I vetted it with Rob Butler he's now with Bird Studies Canada, but he had a joint appointment with Simon Fraser University and also with Environment Canada. So I asked him about it, and he said, yeah, this could work. They were doing some shorebird surveys in Vancouver, and this sounded like a good project. So the next steps were to convince some of our Latin American partners that this was a good project. So what we want to do is that we want to link sites in the Pacific Flyway, focus on western sandpiper and dunlin. We know they're going to survey other species, but we really want to focus on those 2 species. We want to use citizen science as much as possible, and that's what happened in California. They were using citizens and volunteers to do the work. That's not a common occurrence in Mexico or in other parts of Latin America. So we're trying to work on that issue, but the project is underway. The data will be entered into the Avian Knowledge Network. The partners include the Forest Service, PRBO, Bird Studies Canada, Alaska Audubon said they'd be involved, Fish and Wildlife Service, ProNatura, Panama Audubon, Calidris, Aves de Conservación, and we're also working with the Park Service in Peru. The neat thing is it's not the Forest Service leading this effort, it's not PRBO. We have different people, different groups heading up the effort. So in Mexico, it's Terra Peninsular. In Canada, Bird Studies Canada. In the United States, PRBO. And in Central and South America, it's Calidris. So those folks are the experts. They get together. They talk about how to get this done. They've actually conducted 4 different workshops within these different areas to get people interested. In the workshop in Mexico, I think they had 21 or 22 different participants. And after that meeting, there were people who said, we want to include our site. We don't need any money. We'll just do it. Just let us know what the protocol is. So that's exciting. They just finished their surveys this winter. And also a representative from CONAMP, which is a equivalent to the Park Service, they were invited to attend the meeting, and they said, we like the protocol. We'd like to adopt it as our own for the government. So that's happening now. And they also said, we'd like to let you know about a grant opportunity that's available. And the Terra Peninsular hasn't heard about the grant yet, but it's a $40,000 a year grant for the next 10 years. So that's kind of cool if we can get that kind of money. Fish and Wildlife Service has agreed to provide PRBO with $75,000 for the next 3 years to conduct these surveys. And I think this big tent approach has really helped. When PRBO started, when they were doing the surveys, we said, we can make this bigger if you want. Please make it bigger because it will help me out. And so they said, okay. And I think they've seen that. And in Panama, they're working with PRBO because they're both funded by the Packard Foundation, so they want to do some joint work together. And finally, Our next steps are continue to strengthen our network within the Forest Service. I'll have a meeting with folks from the Tongass after this meeting. And then we want to continue to work with existing partners and look for more international partners. With that, I'm done.
So our next speaker is Dr. Ken Lertzman, and Ken comes from us from Simon Fraser University, and we're really excited about hearing his talk, where he's going to try to integrate a lot of across the themes of what we've heard. And Ken has an ongoing interest in how changing climates drives ecosystems and the landscapes and resources available to people who live in them, and how people respond to those changes. So please welcome Dr. Ken Lertzman.
Hello, thank you, good morning. This has been a very interesting session. So I'm going to try and cross some similar boundaries that we've heard about so far and add in a few new ones. So in addition to crossing boundaries between ecosystems or imaginary boundaries between ecosystems, this will be boundaries between disciplines and the also imaginary boundary between the past and the present. So if you're paying attention to the popular literature these days, as well as certain sectors of the academic literature, there's a lot of discussion about human responses to climate in the past, and a lot of analyses of how human societies have or have not responded to various kinds of climatic challenges. Jared Diamond's book is probably the most famous of these kinds of things, Collapse, How Societies Choose to Fail or Succeed. But there are a lot of other, mostly really interesting analyses of how climate has challenged economic and social systems in the past. The general discourse around that is kind of the Jared Diamond sort of thing about sort of the built-in mechanisms that seem to prevent adaptive responses. But the archaeological community has as well come back with another book, Questioning Collapse, Human Resilience, Ecological Vulnerability, and the Aftermath of Empire, which kind of puts forth the opposite view that you can trace down, look at a lot of these purported collapses and look at what happens afterwards and find that in fact there were a lot of adaptive responses, and there were still people there, and they responded in some ways, and they found a way to make a living and often do something very different than the previous society, but they responded and persisted. So what I'd like to do is sort of ask the general question, are there success stories of cultural or social adaptation to climate change in the past? And if so, are there useful lessons that we can bring forward from these for thinking about managing for resilience in the future? And in particular, I'll look at that in terms of a particular case study in the Pacific Northwest and in southwestern British Columbia. So this is basically a story. You can sort of summarize the punchline as climate, culture, and biocomplexity. And we're really putting forward a hypothesis that seems to fit the data better than other hypotheses that have been proposed so far, but still needs some critical testing. And the basic notion is that regional landscape complexity supports an incredible amount of ecological diversity, and that ecological diversity supports social mechanisms for adaptation to changing climate. And this is a story that the kind of the basic archaeological and paleoecological details were published in a paper with my colleagues Dana Lepofsky, Doug Hallett, and Rolf Matthews in 2005 in the journal American Antiquity. We're kind of taking this a little bit farther in terms of the biocomplexity and social resilience story here. And I particularly like to acknowledge my colleague and wife, Dana Lepofsky, who's the archaeologist on this team. All these ideas were really developed in close work with her. So this started as a study, essentially a study of fire history, trying to understand the historical dynamics of coastal temperate rainforests on the south coast, where we were looking at lake sediment records, looking at charcoal and lake sediment records in high alpine lakes, and combining that with a more distributed samples of columns of soil and looking at charcoal buried in those forest soils. And there's about a dozen papers that have been published on the kind of the paleoecology of this work in various places. I'm happy to provide people if you're interested in methods or details, but I'm not going to talk about that here. But these provided us with some really interesting records that essentially give us a full Holocene view of the disturbance dynamics of these forests. Here's an example of one of the soil profiles. These are soils that are very wet. They're very cold. There's snow on the ground for 6-8 months of the year, and it's cold and wet most of the rest of the time. That probably sounds fairly familiar to people up here. And there's very slow decomposition rates, and in fact, we're seeing full Holocene accumulations of material here, where we get Mazama tephras from 6,000-7,000 years ago. We're getting Bridge River tephras that are kind of good place markers, and then these are well dated with AMS dating as well. We can sample these for charcoal, get radiocarbon dates on the charcoal, and start building a chronology of disturbances from this. This is the kind of thing we come up with. So the top graph is essentially the fire record from lake sediments, and the bottom one in black is from the soil charcoal. And there's a lot of really interesting things kind of going back and like looking at lots of fires in the really hot period in the early Holocene, changes through the mid-Holocene. But what we're going to focus on today is this most recent period with lots of fire from about 1,200 years ago to 2,400 years ago. Now, one of the things that's interesting about this is this is not a period that had been identified in the past from pollen records as being a period that was particularly hot and dry or had a lot of fire or anything like that. There are some really interesting things about the different kinds of records that a fire signal gives you than, say, a pollen signal. A pollen signal is giving you a very good kind of broad average of climatic conditions, averaged over a fair bit of period of time as plant communities adapt to changes in weather and climate, mainly in climate. A fire signal is much more, is really a signal about fire weather, right? You can have one bad fire year, 1 year with prolonged spring and summer droughts that leads to a big fire season that's going to dominate that part of the record. That doesn't tell you a lot about climate. That tells you a lot about the tails of the distributions of climate as manifested in fire weather in 1 year. So this is a record that is particularly sensitive to these extreme conditions. We're not saying this is a period of 1,200 years with lots of average warm weather. We're saying it's a period of 1,200 years with magnified tails in the distributions, an increased frequency of years, maybe only every 50 years or 100 years or whatever, but an increased frequency of years with more of those tail fire weather kinds of events. We called this the Fraser Valley Fire Period. It hadn't at that point been described before, but in talking with a lot of other people who are working in this area, it seems to be manifest in a lot of other records kind of throughout the Pacific Northwest in both Canada and Washington and Oregon. So it's a period of about 1,200 years with more fire than any other time in the last 5,000 years. We were looking at mountain hemlock zone forests. These are really wet, snow-dominated forests with essentially almost no modern evidence of fire. They're really hard to burn. There's a lot of fuels, but the fuels are wet almost all the time. And when you do get lightning strikes, of which we have relatively few west of the Coast Range, when you do get lightning strikes, the typical fire is that the tree kind of may scorch its neighbors as it burns and falls down, but the fire doesn't progress much from there. There are really well understood meteorological correlates of fire weather in the mountain hemlock zone. It's essentially the classic sort of prolonged summer drought, a blocking high pressure ridge over that part of the continent. It's really a regional signal. This isn't sort of fire weather in this area. Fire weather in this area is a manifestation of fire weather, of prolonged spring and summer droughts over that whole region. So we can actually use this local signal of fire as an indicator of regional drought. So what's the region we're talking about? The region we're talking about is essentially the lower Fraser Valley and the surrounding mountains and the immediately adjacent Gulf of Georgia. I'm outlining it this way with this polygon, partly because it also is a reflection of a particular cultural region, the ancestors of the modern Coast Salish peoples. The FL and MBC here are Frozen Lakes and Mount Barsirk. Those are the two sites where we're actually getting our charcoal signals from, but it's pretty good reason to think that this is a signal for this whole area. This is a really important ecologically rich area. There's extraordinary terrestrial diversity. It essentially goes from sea level up to peaks of almost 3,000 meters. It has a very broad sampling in the Fraser Valley of the total ecological variability in that region. It's been argued that Fraser River is the most productive salmon river in the world. This is the Fraser estuary, major runs of all 5 species of salmon, and an incredible diversity of runs. So people who've read this stuff around, the really interesting stuff on biocomplexity and diversity in Bristol Bay salmon stocks, that's that kind of a story. It's an important area for overwintering waterfowl. Essentially, Boundary Bay was referred to in the last talk as part of this system. And it's the focal point for an enormous ecological subsidy from the interior of British Columbia. So in green here is the Fraser River watershed. It's the largest river in BC, the 5th largest in the country. It's almost as large, the watershed's almost as large as California, and has an enormous river volume. But all of this huge area focuses down in the estuary, and there's a tremendous subsidy of nutrients, of material, of the productivity of the interior British Columbia passes through here. And so that red is the Fraser Valley, which is essentially our focal area. Okay, back to the past. So we've got we're looking at fire history here. I'm going to focus in the next graph just on the part that's outlined here in blue. So hold those two, the red and the blue lines there and the black lines in your mind. So here's just that section. So again, in the top, the charcoal signal from the lake sediment records, and then the bottom, the charcoal signal from the soil records. We're looking at this and trying to sort out different things, and Dana essentially said, this maps remarkably well on the timing for the Marpole phase. So the Marpole phase is a particular period of cultural development that the archaeologists see in this area. It's very well described, had been very, very well described in the archaeological literature for the previous 20 years. And so we took all the radiocarbon dates from Marpole phase archaeological sites and plotted them here. And that gray polygon here, appearing and disappearing there, is basically just all of the dates. We didn't subsample them. We didn't go and choose them that fit in that period. That's just all the cultural dates from the Marpole era. And we said, oh, this is really strange. It must be a mistake. We worked really hard to show how there was some kind of an artifact from radiocarbon calibration, and try to figure out reasons that you couldn't have this remarkable superposition of the cultural dates on the fire period, but we couldn't figure out any reason why this was wrong. And so instead trying to figure out why it might make sense. A little bit about the Marpole era. The interior dotted polygon here is sort of where those critical sites come from. So all of those dates came from an area that is removed by about 100 kilometers from our sampling sites up at the eastern end of the valley. Again, further suggesting these are providing a good regional signal. The Marpole era is really characterized by essentially 1,200 years of rapid cultural change. It exhibit changes in technology, changes in the development of new sort of stone technology for processing fish, changes in basketry. It's really the time when the development of basketry technology surged. Changes in decorative patterns on the bottom left of this and in the center. Changes in that it was a period when they were adding a lot more decoration to functional tool items, like the nipple-topped mauls on the bottom right. It's also a period when there was a lot of changes in mortuary patterns and in burial patterns and in housing. It's a period when they went from having relatively small houses to very, very large houses. Large houses in the archaeology community are really an indicator of increasing complexity, increasing social complexity in societies. They're structured in space. People analyze the space within the house in terms of how that reflects power structures within family groups. Larger houses means more social complexity embodied within a single living area. It's also a period when there seems to be a whole lot of movement, especially movement from the western part of this region on southern Vancouver Island and the Gulf Islands over to the eastern part of the region in the Fraser Valley. More regional synchrony and homogenization in burial patterns, housing patterns, stylistic patterns, essentially indicating this kind of a movement and coming together of people. There had been a lot of previous hypotheses put forward as to what was driving the Marpole phase, and they're all really different ways of trying to get at explaining the development of social complexity during this era. They all focus on intensive use of Fraser River salmon. They focus on variability in salmon over time, differential access to resources. They posit cooler climate leading to declines in other resources, or megathrust earthquakes that there's no evidence for. Population pressure leading to resource intensification, or diffusing of knowledge about technology. In general, various kinds of social responses to differential access or scarcity of resources. But they tend to all focus on salmon to the exclusion of other resources, and though salmon was important, we know people don't just eat protein, they eat plant resources. They need a lot of other things besides salmon to live. They don't really address what we know were the linked regional scale ecosystem dynamics of riverine, terrestrial, and marine systems. And they're often not really well supported by either the paleoecological record or the archaeological record. So we tried to come up with an explanation for this pattern that linked the known cultural phenomena with our fire history data, that essentially tries to tie in the kind of the missing elements from previous hypotheses. And it's kind of positing then a link between biocomplexity at a regional scale and social resilience. So the first question here to ask then is, well, if we see a lot of fire, what were the ecological effects of fire? Kind of what are the correlates of fire? So our known starting point here is this observation that there was a lot more fire during this 1,200-year period. What can we infer from there? Well, as I said, we understand a lot about fire weather and fire behavior in those systems. And so basically it's a pretty easy step to go from lots of fire to there were a lot more years with fire weather, kind of more fires happening during frequent hot, dry summers and falls. We know that there are a lot of correlated changes. When we get these kinds of years, there's a lot of correlated changes in oceanographic conditions, changing patterns of processes in freshwater systems, and they cause a lot of changes in the mosaic of cirral stages on the landscape. The next step in this is saying, well, what are the consequences of those kinds of changes for the abundance and predictability of both aquatic resources and of terrestrial resources? And so the chain of inference goes something like this, with the marine sequence, marine pathway on the left and the terrestrial pathway on the right. We know that these tend to be correlated with periods with these years tend to be correlated with high sea surface temperatures, and I'll follow the marine one. Those are associated with the changes in coastal marine productivity, increases in predators on herring and juvenile salmon, and decreases in the local predictability of salmon. For instance, the Fraser River sockeye will change their migration route. Instead of going on the inside of Vancouver Island to get to the Fraser, they'll go on the outside. So if you're living on those islands on the inside of Vancouver Island and waiting for the salmon to come by your normal fishing spot, you're going to be in trouble because they're still there, they're still heading to the Fraser, but they're following a different migration pathway. The abundance of the salmon isn't necessarily changing, but the predictability of the salmon in any given spot out in the ocean is going to be wildly different. On the shore, we know that associated with a lot of fires, there's a lot more nutrients and sediments being mobilized. This is going to have positive effects in some places and negative effects in other places. There will be changing freshwater productivity and hydrology. There's going to be increased access, and I see my Macintosh icons here have not translated completely correctly. That's supposed to be increased access to increased early seral areas and access to high elevations. Increases in access to wildlife and plant resources at high elevations, which the elders we're working with from the modern First Nations there have told us is very important to them. And probably decreased predictability in small stream runs. If you're on the Fraser where all of those big salmon runs are coming through, you're probably fine, but if you're depending on small coho streams and stuff like that, again, you sort of might be fine, but the predictability of where is going to be good is going to be decreasing. Overall, you're going to get regionally the increased importance of the Fraser system, of this kind of core Fraser Valley system. It's a large multi-stock river with access to diverse terrestrial and marine resources, plant and aquatic resources. It's going to benefit from all of these portfolio kinds of effects. I'm going to skip through and finish up here pretty quickly. The basic notion then is under changing resource abundance and increased year-to-year uncertainty, the Fraser Valley with the greatest diversity of terrestrial and aquatic resources will be the most desirable place to be. And being able to provide access to those resources is going to increase the social status of the elites in the valley. So we're essentially seeing that social networks or social capital, allowing your relatives from the islands to come and access your resources, is going to be used to offset resource uncertainty during these times of environmental change. And these sort of social mechanisms for accommodating changing climate in the past are still fundamental features of modern cultures today in terms of these social connections between the eastern and western parts of the system. There are a bunch of predictions of this that we could use for evaluating the hypothesis I won't go into, and I'll finish up then by saying, so what factors supported resilience in this socio-ecological system? So factors supporting ecological resilience are essentially spatial subsidies, both spatial subsidies to the Fraser Valley system from the interior of the province and from the marine systems. This enormous landscape diversity within the Fraser Valley gave them access to lots of different kinds of resources. Spatial refugia within that system kind of provided some buffering. And these portfolio effects associated with large range of life histories within the system, again, gave buffering with respect to sort of the vagaries of environmental change in any particular place. Factors supporting social resilience were really largely associated with these sort of broad social family networks and the social capital embodied in those. And opportunities for what's essentially prey switching, sort of the opportunity to take advantage of these portfolio effects by switching the prey resources that you're focusing on, and the demographic mobility of those people. So then really the question at the end of this is, are these things that we can manage for, right? Are these kinds of spatial subsidies and social capital things that we can try and enhance in modern systems? So basic idea is biocomplexity supports cultural resilience, and for us as researchers, kind of this really emphasized the importance of a non-trivial understanding of both the social mechanisms and of the ecological complexity. The previous hypotheses kind of had one of these but not the other. The role of physical landscape complexity was really emphasized for us. And we think that the Fraser Valley fire period is probably a good model for the future for kind of increasing event years in the tails of the distributions. But we have in this system a gross erosion of these mechanisms that support the biocomplexity end of things. It really emphasizes the importance of integrated strategies for managing terrestrial freshwater and marine systems, again, which is something we talk about but aren't really doing. So I think we can manage these for these factors supporting resilience, but we're not doing it so far, and it's going to take a lot of careful thinking and a lot of hard work trying to pull these kinds of stories together in a way that allows us to actually bring them forward into management. Thank you.
Quick question for Ken? All right, thanks. So we're very fortunate to have our last speaker as John Mankowski, who's the coordinator of the North Pacific Landscape Conservation Cooperative. And we're glad to welcome John because he brings together both a rich experience in natural resources as well as a great depth of experience in terms of the political arena. He's worked for 5 years as the governor of Washington's advisor on natural resource issues, and has worked in various other elements in state and federal organizations. So to conclude and kind of integrate some of the political as well as natural resource issues, please welcome John Mankowski.
Thank you for that introduction. Thank you for staying in the room this long. I'll do what I can to sort of pick up the tempo. I assume there's no penalty for leaving early here. I have a difficult challenge in that speaking last means most folks have made your key points, but they didn't make all of them. But I do want to make a couple of important remarks. One is, Rick did a great job laying out the problem. The problem, as we're dealing with this coastal temperate rainforest, is that we've fractionalized our work and our organization so small that when the large-scale issues affect us, and most of our challenges these days are large-scale, whether it's climate or forest health or cultural issues, we're not prepared to do it because we're down here doing our work of the past. So that's kind of my main thesis. I want to talk about also the fact that both Jim and Gretchen and Steve and Ken all made that point. We're dealing with things at the wrong scale, whether it's salmon or bird conservation. We've got to look at landscape scale organizations if we're going to solve landscape scale challenges. So what I want to do, in less time than I've been allotted, is talk quickly about landscape conservation cooperatives, what they are, what they're designed to do, how they get at these larger scale conservation issues in North America. I'll talk about some of the specifics of the North Pacific LCC, of which I am the coordinator, and Mary Mahaffey, I think, is somewhere here. She's the science coordinator. Some of you in the room are on the North Pacific LCC structure. And then I want to conclude with a little bit of a sense of science projects and direction that we're going. Again, just not to grind this edge too sharp here, but the kinds of conservation challenges we're facing today, whether it's Southeast Alaska or British Columbia or Pacific Northwest or even beyond, is recognizing the fact that we're in a more complex world these days. The kinds of issues coming across our transom affecting governor's offices, federal agencies, natural resource managers, really are more complicated. They require us to anticipate change. We're not dealing in a static world. We can no longer manage for what used to be or what is today. We have enough information to talk about the future. We know now what climate will look like in some period of time, how that will affect sea level, how that will change habitat. So we have a responsibility to start to think about these larger scale future scenarios and incorporate that into our natural resource management. We're also doing this in a tough world. We're doing it in a tough world where there's reduced agency resources. Tribes I work with are hungry for resources and capacity to engage. State agencies, if you come from state agencies other than the state of Alaska, you're in pretty dire straits financially. Federal agencies are going to be in the same situation as well. So one of the really underlying premises for landscape conservation cooperatives, and part of the reason I took this job, is I think it helps us get at this question in the bottom in yellow. And that's, how can we really advance conservation and sustainable resource management in a world of landscape scale stressors and change with limited resources and limited decision space. By limited decision space, I mean now more than ever, we have boundaries given to us by court cases or different jurisdictions that complicate the work that we do. In my previous world working for the governor, I think I had the toughest job. She always thought I was the slowest person because other advisors that worked for her had simple portfolios. If you're the transportation advisor and a bridge fell down, you made one phone call and you fixed the bridge. Or if you were in the law and justice world, you made a couple phone calls and you dealt with, whatever the issue was in prisons. In natural resources, when I had a challenge, and you guys all know this, I'm not telling you anything different, you had to bring in affected tribes. You were bringing in 3 or 4 federal agencies, 3 or 4 state agencies, NGOs in the private sector. But that's how natural resource the world works. It's complicated. It touches a lot of people, and that's frankly why I'm in the business. So the framework of LCCs were established, 22 LCCs were established across the North American continent in 2009 by secretarial order. Secretary of Interior issued an order that created these LCCs to help get at some of these issues, and at the same time and in the same order, he also created the Climate Science Centers. And we're in the geographic footprint of the Alaska Climate Science Center. I don't see Stephen Gray in the room now. He was here earlier today. So the Climate Science Centers were established, so were the LCCs. The LCCs are management science partnerships that are really designed to address these large-scale stressors that are affecting natural resource management in the U.S., but also north into Canada, Alaska, south into Mexico, and including the Hawaii and Pacific Islands. Designed to get at these large-scale threats, to prepare ourselves to have partnerships and funding and resource and capacity so that whatever the regional threat is, whether it's new science or climate change or invasive species, that we have partnerships and science and capacity to address those things. What will LCCs do? Again, at a high level here, they're designed to leverage funding, staff, and resources. Many of us have, in this room, we have a tremendous amount of leverage and resources at our disposal. We're not all using it in the same way at the same time. But if we were to do that, if we were to leverage those resources and focus on some of the most critical climate-related science questions affecting the temperate rainforest, we can do a tremendous amount of good. That's part of the concept behind the North Pacific LCC. To the extent we can, we'll develop common goals. Let's face it, we share a common ecosystem. We're all dealing with the coastal temperate rainforest and adjacent marine waters. Why isn't it that we have a common partnership or management organization that operates at the same scale? Why have these partnerships efforts? Many of you have seen this report, others may have not, but this was a report that came out about the same time LCCs were being thought of and created. It was created by the Lincoln Institute, and they looked at a pretty intensive study about the barriers to landscape conservation and what they really kind of boiled down to. There are a number of successes. We all know about some of the largest scale approaches to landscape conservation, whether it's for ungulates or habitats or outdoor recreation. But they identified some of those barriers to landscape conservation. And I found a very interesting correlation with the purposes of what LCCs are. And it's the lack of scientific information. No one ever has enough. There's a tremendous amount in the room today and yesterday. But is it enough? Never enough. And is it in the hands of the people that need it? Is it in the hands of the resource managers that have to make decisions about permits or decisions of natural resource tribal leaders who have to make decisions about how they manage their lands and their resources? There's also the lack of capacity to organize. So LCCs are a lot about getting people together, breaking down those boxes, and believe me, there are many. We create a few boxes, but I would argue there's a net loss of boxes once the LCCs have organized themselves. And a lack of a strategy to coordinate. One of the benefits of coming to conferences like this, the kind of late conference buzz that you get, is you've met a lot of people. You've shared a lot of information. You've made commitments to follow up with additional people because you found like partnerships. The LCC is designed to sort of institutionalize that, not make it an endless conference because nobody could handle that. But you'd have to agree, at the end of a conference today and the previous day, we're feeling good about what we do. We're anxious to get home and carry out. But the problem is we sort of go home back into our silos, look at our 80,000 emails, and do all the things we didn't do, turn our phone calls, and find yourselves back in a traditional way of sort of working in your own organization. LCCs are designed to sort of institutionalize these partnerships and also take advantage of fragmented financial investments. LCCs are generally funded by the Department of Interior. Fish and Wildlife Service puts a lot of money into it, but so do the partnership organizations. And to the extent LCCs grow and mature, we think we're going to attract additional financial resources, and it will in fact be a new way of doing business. So let me shift gears now and talk about the North Pacific LCC. This map looks a bit familiar in that it exactly encompasses the Pacific coastal rainforest, although it goes a little higher in elevation than the rainforest itself. These LCCs were designed primarily on bird conservation areas and looking at watersheds as well. And the one that I'm managing, the North Pacific, obviously runs from south central Alaska to northern California. We're all familiar with the statistics. It includes Alaska, British Columbia, Washington, Oregon, and California. And it generally runs from the crest of the coastal mountains down to the coast and includes affected marine areas too, as well. The LCCs are management partnerships led by a steering committee. I'll try not to talk too much about the boxes, but it's important to understand because we really value the partnerships of the different agencies and states and tribes and First Nations. And we do that showing this commitment through this organizational structure. The box in the top middle is the steering committee. It's a committee of leadership, both from tribes, federal agencies, states, and a couple of other partnerships. I'll talk about membership on that in a minute. But that body really sets the goal, and the focus and the mission for the LCC in this region. I operate in the box to the right. I'm the staff. I'm the coordinator for the LCC. And to the extent I have additional staff, like a science coordinator, being Mary Mahaffey, or others, will function in that box. And our job is to sort of do the work of the steering committee and help manage and operate the strategic plan and the various subcommittees. This LCC was officially created in December. We're only 6 months old. So I'm talking as if I know everything, but the truth is this is very formative still. And it's experiment and it's growing. And that's the good news, because you can influence it as we go forward. Importantly, there's a couple of committees I want to point out, and subcommittees. The 3 boxes below are the subcommittees established by the steering committee in their charter in December. This is all available on our website if you want to read the details. The committee in the middle is the one that's been active and working so far. It's the Science Traditional Ecological Knowledge Subcommittee. Their job is to help create a 4-year science strategic plan for the steering committee and make recommendations on annual funding priorities for the steering committee. I also want to point out that when and where needed, we will form subgroups. It's both a blessing and a curse that the North Pacific LCC spans a huge latitudinal range from Alaska to Northern California. It's a blessing because it is the ecosystem, but it's a challenge because the issues are different. While we are talking about similarities in the forest and the aquatic system, there's a lot of differences, as many of you well know. So to the extent we want to focus time and energy on issues and funding and science needs in certain subregions of that, we will allow ourselves to do that through this box on the bottom. The box on the top left is very important. I want to point that out. This is not a subcommittee, but a committee, a parallel committee, comprised of tribes and First Nations. It's really an opportunity for tribes and First Nations to talk about how climate is affecting things that they care about: cultures, natural resources, a variety of things that both we will cover through the steering committee, but also things that are maybe more just personal and important to tribes and First Nations. Any tribe and First Nation that wants to participate is welcome to attend, and we'll make sure that actually becomes effective and a working group. The information from that Tribes and First Nations committee is then going to be conveyed to the steering committee to the extent tribes and First Nations choose to share that information and their priorities relative to science and climate-related science for things that they care about. The last box I want to reference is the lower left box, and that recognizes that in the North Pacific LCC there is a broader partnership community consisting of NGOs, private sector, people in the timber industry, agriculture industry, shellfish industry, who probably care a lot about climate and how it affects what they manage. We want to know what their priorities are, what their research priorities are. Consequently, they will want to know what some of the results and information of the LCC are that can help them make decisions regarding their management practices. Again, I mentioned the steering committee. I want to talk quickly about who's on that steering committee. All the federal agencies that touch natural resources are on there. I'll quickly buzz through these. Most of you know the acronyms. I apologize for those of you on TV or those that don't. But the Bureau of Land Management, Bureau of Indian Affairs, National Park Service, NOAA, U.S. Fish and Wildlife Service, the Forest Service, USGS, NRCS, and EPA. And in many cases, there's dual representation. In many cases, again, because we have the further range up in the Alaska Gulf Coast, contrasting with the Northern California, Oregon, and Washington, there's dual representation. So we have representatives both from the science and management side, senior representatives in these agencies. In many cases, there's 2 seats at the table. Say, for example, the Park Service. The Park Service has an Alaska area representative and one from the Washington State area. That's also occurs with the Fish and Wildlife Service and the Forest Service and others. We also have very active participation from our Canadian friends. The Canadian Wildlife Service has a seat at the steering committee, as does British Columbia. Tribes and First Nations have 5 seats at the steering committee. Again, we know and understand that tribes really are reluctant to speak for other tribes, and that's why we have the box on the left where everybody can speak for themselves. But at the steering committee, we really value tribal input, and we have reserved 5 seats, one for Alaska area tribes, and Leilani Knight, I think she's in the room here. If not, she should be. She's on the steering committee, and we're still securing some representation for British Columbia First Nations, and we have the seats filled for Washington and California tribal reps, and we're still working on the Oregon tribal rep. We also invited the states. We want the work that we do, North Pacific LCC, also to serve the needs of the states. So we asked the governors of each state to submit a name to be representative on the steering committee. And in Alaska, we have Alaska Department of Fish and Game. In Washington, it's Department of Fish and Wildlife. Oregon, it's the governor's office, and in California, it's Cal Fish and Game. Pacific Coast Joint Ventures is on the steering committee. And lastly, we have a number of non-voting science partners on the steering committee because we want to make sure as we talk about the priority science needs of the coastal temperate rainforest, we're working very closely with others that are doing science. This isn't the whole organization. We know there's universities and others. We have the climate science centers, both in Alaska, the Northwest Climate Science Center in Oregon, and then Southwest Climate Science Center, once they're created, are on the steering committee. We have the NOAA RISAs that are engaged, as well as the sort of British Columbia analogies, if you will, to the climate science centers that we have in the U.S. And that's the Pacific Institute of Climate Solutions and the Pacific Climate Impacts Consortium. So that gives you a sense of what the steering committee is. It's natural resource leaders, tribes, state, partnerships, federal agencies coming together physically twice a year, over the internet and telecommuting far more often than that to carry out their mission. And this is the mission. This really, I apologize for all the words here, but they're really important words. The purpose of the LCC, the North Pacific, is to promote development, coordination, and dissemination of science, to inform landscape level conservation. We're not going to do a plan. We're not going to tell people how to manage their lands. We're going to help gather good information to help inform land management decisions, conservation and sustainable resource management in the face of climate change and related stressors. We're talking about large-scale climate change and related stressors. A couple of the goals I want to highlight are really, our function is to maximize the ability of resource managers to make informed decisions. We're going to talk about identifying transboundary and landscape level challenges and cultural resource needs. We had a meeting last night with some of the Alaska area tribes to talk about what are some cultural landscape and cultural resource information needs that they have related to climate that we can help tackle and identify. One of the areas we're spending a lot of time right now is identifying the priorities for applied science. We're spending a lot of time with resource managers on the ground who do permitting, who look at various projects, working with federal or state agencies, and tribal resource managers who are managing fisheries and other lands to find out how, when they make decisions, what sort of climate science do they need? What sort of climate-related science would they like to have? What sort of science is out there, but they're not able to use it because it's not in the right format or fashion. Once that information is obtained, either through the climate science centers or leveraging our partnership with universities and other researchers, we want to spend time making sure that that's available and accessible to all partners within the LCC. Lastly, we want to talk about coordination and efficiency. I think we all understand that the kinds of science that we need to have access to make natural resource decisions. No one entity can afford to create their own climate science center within the state of Oregon, the state of Washington, the state of Alaska, and across all federal agencies. Really the crux of this LCC is the opportunity to come together to talk about joint priorities for climate-related science, leverage opportunities to gather that science, and make sure it's widely available to natural and cultural resource managers throughout the LCC. I'm getting the 5-minute mark, so I'm going to speed up just a little bit. So in FY11, fiscal year 11, we funded 11 projects. Many of them focused on landscape scale analysis information. We looked at climate effects on wetland ecosystems, forest soils. We're funding projects looking at sea level rise both in Humboldt Bay and elsewhere. We're looking at vulnerability assessments, talking about how which species and habitats might be most vulnerable in the nearshore areas, and looking at a couple of case studies in the Willamette Basin and in British Columbia. These are projects we funded last cycle. We have 4 projects looking at conservation priorities. What are the conservation priorities that occur in the Pacific Northwest and the Northwest Rainforest in a world of changing climate? So we're funding studies to help us identify what some of those priorities might be, whether it's at-risk wildlife migration corridors or changing bird distribution patterns. I think there was a mention earlier today from the folks at PBRO. They received one of our contracts in the second bullet there. So you can see here's a large number of partners receiving funding from the LCC that helps get management-related information out and available to people that need it. We're also spending time and energy on workshops and information, part of what you're doing here. We're conducting literature reviews and literature syntheses through UW and UAS. We are looking at doing expert focus groups through the National Wildlife Federation, and they made a presentation yesterday that talks about some of the products they've already created for us. We've funded a data integration workshop that occurred a few months ago. We're looking at doing that again this next year to integrate data across Alaska, British Columbia, and the lower 48 within the LCC. And we're looking at regional workshops. We help fund this workshop you're here at today, as well as some other climate-related conservation efforts. I'll skip through some of these early examples. What people are telling us they like to see out of the LCC in terms of their science needs, you can see some of these on the screen behind me. What we're doing is taking our time going through a very structured decision-making process, bringing people in the room, talking about their science needs, what information already exists out there so we don't replicate that, and how do we fill the gaps to make that widely available. These are some of the things that we're hearing from our resource managers and professionals. We're also hearing from them that they would like the LCC focus on a couple of key factors: help provide capacity to address climate change, help provide information portals, help the practitioner who has to make resource decisions in this rapidly evolving world get ready access to tools that they can use and build and facilitate partnerships. Our priorities for FY12, we have 5 priorities that we've adopted and we're now implementing. One is to take a look at a literature review and information synthesis for the terrestrial habitats within the entire range of the North Pacific LCC. We've already completed the work through the Wildlife Federation for marine habitats and aquatic freshwater habitats. So this completes that work. They're also asking us to look at data management platforms. So at the landscape level of the North Pacific LCC, how can people find out what data and information are available to help them do analyses, to access other data sets and do simple analysis at a large landscape level. We're looking at doing an inventory of what GIS data are out there, data dictionary types of things, and creating new data layers where and when appropriate, mostly on the transboundary types of challenges. And lastly, I want to point out we've just released an RFP to help us better incorporate traditional ecological knowledge, about how climate change affects cultural resources into the work of the North Pacific LCC. That was released a couple of days ago. It's on our website. I know that a number of the folks in this room, tribes and others, are interested in making presentations. So a couple of key summary points about the LCC I hope you remember when you go home. Number one, that the LCC is a viable framework for transboundary integration of climate-related science and information needs. We're not trying to do everything for everybody. We're going to focus on climate-related science and information. We do have a broad footprint. It happens to exactly coincide with the coastal temperate rainforest. I don't know of any other organization that operates at that scale. We have the key partners at the table. We want to build more NGO partnerships. We know we're light there. We're going to do that as time goes on. And we're just getting started. We've been in place now for 6 months. We've had one funding cycle. We have a very active steering committee that's on the job. We'll be developing a strategic plan, a 4-year science plan, and an annual work plan. And it's important to know the dual focus. And the dual focus is on both cultural and natural resources, and in our world, how climate change is affecting those, including both traditional knowledge and Western science, and we want to be inclusive and collaborative. We're in the phase now of building partnerships. This is my first opportunity to come to Juneau and talk to some of the leaders in Alaska about the LCC. You'll certainly hear more as time goes on. If you can't wait to hear more, you can visit our website, which is on the screen behind me. My contact information is there, as is Mary. So I hope I didn't race through that too fast. I have plenty of coffee, so I know I zipped through that. But I wanted to give you a sense for what LCCs were, a little bit about what the North Pacific LCC is, and offer an invitation for you to engage your entity and your party through the various structures that we've created through our organizational charts. So with that, I will conclude. And are there any closing remarks that we have to make? Or are we free for lunch? Oh, it was less than 20 minutes, wasn't I?
I'll just make a couple of concluding remarks. Thank you all for coming and staying. We did delay the other sessions, so they sort of went through the line first, so now we'll be just on time. I do want to really extend a thanks to our timer, Adam Taylor. Thank you very much. Tough job today. You did a great job. And Brittany Leinhardt for changing our slides and all the support she's given. So thank you very much for coming, and have a great lunch.